There's this really corny old joke in programming circles. It goes something like this. A man is headed out to the grocery store and his wife turns to him and says, "Hey, while you're out, buy some milk." Then the man never returns. The joke here is that she never gave him any explicit instructions on how or when to return, so he's now stuck in an endless loop, buying milk and never coming home. Yeah, I warned you ahead of time that it was corny. So this joke, which is terrible and should never be told in polite company, does contain a kernel of truth, a nugget of wisdom inside of there. And it's about programming. It's about how programs and computers will execute our instructions even to a fault. They will run and run even if we tell them to do something, well, kind of dumb or kind of stupid. We have names for all the different errors that arise for these types of problems. Heap stack errors, buffer overrun errors, division by zero, right? You cannot divide by zero. That is not a physical thing that you can do, but you can certainly write code that will try to divide by zero, and when the computer tries to execute that code, well, problems arise. As of recording this, computers cannot yet figure this out for you ahead of time. So while I can certainly turn to my wife and say, "Hey, while you're at the store, buy a gallon of broccoli and a couple of heads of milk," she's going to know, she's going to be able to say, "Oh, he meant a gallon of milk and a couple of heads of broccoli." Computers can't do that. When they look at our code, they cannot figure out that we've done something wrong and ahead of time fix our code. So we need to take great care in structuring and organizing our code to avoid these problems as much as possible, to expose them as early in the process as we can. There are a number of different guidelines and principles out there about writing good code that help solve this problem for you. The DRY principle, DRY, it stands for do not repeat yourself, or the KISS principle. I bet you know that one, right? Keep it simple, stupid. And the whole idea behind these principles is to avoid these problems that I'm talking about, to help us write code that is legible for computers and legible for people, that is structured and organized so it can be easily maintained, and that is testable. That third one is really, really important. We want code that is testable so we can expose these potential problems earlier in the process. After all, if these problems come up at the end of the process when our users are using our code, we have a word for that. It's called bugs. Those are no good, right? So what I want to talk about in this skill is some of the different structures and abstract ideas that we can apply in most programming languages, not necessarily all, that are going to help us implement principles and help us achieve this kind of code organization, this kind of code structure, so that we run into these problems as little as possible. I think it's pretty interesting stuff, and it's a little bit abstract, but it does have practical implications, which we're going to talk about. We'll talk about control flow statements. We'll talk about methods and functions, organizing our code, encapsulation, isolation, separation of concerns. I want to talk about architectural paradigms like object-oriented programming. You've probably heard of that. I'd like to talk about what that means and why we do it. So thanks for joining me on this journey. I hope this has been informative for you, and I'd like to thank you for viewing.